Hi guys, welcome to the next session. The previous session, we have seen how our reinforcement learning system tries to explore the environment when it is in the beginning stage. So when the game is in the beginning stage, agent knows nothing about the environment. So it explores through taking the actions without knowing what would happen as a consequence. And through this, it tries to get a idea what the environment is and creates a knowledge bank about the environment. And this knowledge bank consists of the fields, action, state, and corresponding reward of participant. So once this bank is available, then we can get into the next phase of action, that is the exploitation. The problem with exploration is we just can't keep working randomly because we are not sure that the next random action will always get a better results. Therefore, when it is random, then the result may also be random, so it will be either positive or negative, can be anything. But once we have enough knowledge about the system, once we have enough knowledge about the environment, then we can stop exploring and shift to the next version, that is the exploitation. Here, the agent chooses the best known action based on the knowledge. So, at any given state of the environment, the agent looks at the knowledge bank and sees for that particular state which action produced the best reward. So, that action will be repeated. And this exploitation is used only when the agent has enough information about the environment because now the agent is depending only on the knowledge, and if the environment is not fully known, then we may miss the best possible actions that can produce best possible outcomes because they were not in the knowledge bank. So they might not have been explored yet. Therefore, just exploitation may not lead us to the best possible results. For that, we must ensure that enough information about the environment is available only when we go into exploitation. So this is useful in case of deterministic or well-explored environments. So the environment is of deterministic type. So when we take up some action at any given state, then the next step and the reward should remain same when we take the same action in the same state another time. So it should be deterministic. That means from state S1, if action A1 is taken any time and if it goes to state S2 and produces a reward R2, then anytime in future, if the system is in state S1 and the agent takes action A1, then the system should move to state S2 and produce reward R2. So this is what we call deterministic, and this should be useful only when we have a well explored environment. So exploration is done to its maximum level, only then we can expect better results through exploitation. So the goal of exploitation is to maximize the immediate reward, and this relies on either a value function or action value function, which famously known as Q function. So details will follow in the coming sessions. Just for continuity, we are talking about this. So the goal is to maximize the immediate reward. So to maximize the immediate reward, we either use the value function V or the Q value, that is a action value function that is appear. So for every action, what is the value produced? Then let's say what different types of exploitations are possible. So one is the greedy policy. So here, the greedy policy always selects the action with highest estimated value. So we have estimations that at any given state for a given action, what is the estimated value we have. Then among all the possibilities, whichever value is highest, that action will be taken. The process of greedy policy will be simple, but it may get stuck with the local optima. It may not guarantee to reach the global optimum. So it may get stuck at any local optima. So that is one problem we do have with this greedy policy. Then we have exploitation in greedy. So that is earlier way we had seen that decaying epsilon. So here epsilon was the time in for which it was being explored, which means that 1 minus epsilon is the time for which the system will be exploited. So with the probability of 1 minus epsilon, this agent will be exploiting. So as the value of epsilon decays, the policy becomes more and more greedy. So in the beginning, exploration is given more importance, but as time progresses, the value of epsilon keeps reducing. Therefore, the probability of exploitation will increase, and hence the policy will become more and more greedy. Then we have a method called policy gradient methods. Here, we directly optimize the policy such that the reward is maximum. So the learned policies become increasingly exploitative over time. So whichever policy is done by the system will be exploited more and more over time. So the one which gives better rewards will be exploited again and again. Then the other type is value iteration or policy iteration. This finds the best action based on the value of each state. Yeah, there are some risks of over exploitation. If on one side, if it is over exploration, then we will not be uh, following the knowledge available. So that is the problem with over exploration. But on the other hand, or exploitation also provides problems. So one of them is a sub-optimized policy. If enough information about the environment is not known, then the optimized policy, whatever is created, may not be the best policy. It may not yet come to our notice, or it may not yet come to the learning process notice because it is not given sufficient time for exploring. So we get a sub-optimized policy. Then there will be lack of robustness. So we can't guarantee because we have more intensified on the exploitation one. That means exploration is done for a limited time, and most of the time we are trying to exploit from the available knowledge, and the available knowledge may be limited because of less of exploration, and hence our system will not be robust enough to work for any kind of situations. And definitely, generalization is out of question because it's strictly following a set of rules, and that set of rules are defined with minimum knowledge about the system, and hence there will be problem of generalization. So let's try to understand the two processes what we have seen, exploration and exploitation. Just to see, let's see one example, training a robot to navigate a maze. Here, when we begin, the robot knows nothing about the maze, doesn't know where it is, doesn't know where all the parts are there, where the blockings are there, where the final target is there, what are the parts that can take to reach the final path and all that. So nothing is known. Therefore, it tries different parts. So it will start working, moving this and that side randomly. And if it gets stuck somewhere, it comes back, tries another way, comes back, tries another way, something like that. So this is done with no information about whether it is doing correctly or wrongly, whether it is doing in right direction or wrong direction. Nothing is known here. So this process is what we call exploration. So there is nothing to guide us. So the robot tries on its own and explores the environment, and once it explores, then it discovers many paths to reach the goal state. And then once it knows multiple paths to reach the goal state, then it can discover one path that always reaches to the goal state the earliest. So that's a best one. So once multiple paths from the source to destination are identified, then it finds which is the best path, and this best path will be used in the next coming operations again and again. So that is, it is now making use of its knowledge that it knows that this path is the best path. So it exploits this path to maximize the reward and finish the task as quickly as possible. So to start with, anything is unknown, so nothing is known. So it starts exploring, tries all possible ways without any guidance, without any information. Then it identifies various paths to reach the goal, and then finds which is the best path, and then in future always tries to use that path. Now the question is it really the best path? No, not guaranteed, because when it is doing exploration, it has found some number of paths to reach that goal. And if that path has got the global optimal path, then yes, it has done its job perfectly. But if this exploration could not find the global best path, then in future when you are exploiting, we will be working on suboptimal results only. Definitely, we won't be able to reach out that the best path because to reach that we have to leave our policy and try something new. And trying something new is what we call exploration. But once we stop exploration and then get into exploitation, then there is no chance of getting a better path. So these are the some problems we have. So one side exploration, other side exploitation. So exploration always cannot be used all the time because each time it is trying to find another route and all that, and we can't guarantee which is the best one and all that. Whereas exploitation, if the global solution is unknown yet, then we are not having the best solution. So there is a trade-off between exploration and exploitation. So depending on the situation, we need to identify some solution to work out with this trade-off. So that's some details about exploration and exploitation, and finally we could understand through one simple example. So many more issues to come in the next sessions. So keep watching. Thank you.